Good day and welcome to this online lecture on the topic of assessment of physical activity with doubly labeled water. I am Dr. Sember and this is blended learning course in collaboration between University of Ljubljana and University of Porto. This lecture, we will explore and discuss the key concepts and practical applications related to assessment of physical activity with doubly labeled water. By the end of this lecture, you should have a deeper understanding of assessment of physical activity with doubly labeled water and be able to apply the knowledge gained to your own life or work. So, why don't we start? Doubly labeled water is a technique used to measure an individual's metabolic rate by tracking the elimination of two isotopes of water from the body. Doubly labeled water uses a stable isotope of oxygen and a stable isotope of hydrogen, both of which are non-radioactive and safe for use in humans. The process of measuring energy expenditure using doubly labeled water involves several steps. 1. Isotope dosing. The individual drinks a measured amount of water containing a known amount of stable isotopes of oxygen and hydrogen. The isotopes are incorporated into the body's water molecules and are then eliminated from the body through urine and respiration. 2. Sample collection. The individual collects urine samples and breath samples at specified intervals after dosing. Urine samples are collected over a period of several days, and breath samples are typically collected for a shorter period, usually 4 to 8 hours. 3. Isotope analysis. The urine and breath samples are analyzed to measure the isotopic composition of the water molecules. Specifically, the ratio of oxygen isotopes and the ratio of hydrogen isotopes are measured. 4. Calculation of energy expenditure. The elimination rates of the isotopes are used to calculate the individual's total energy expenditure over the period of measurement. This calculation involves several equations that take into account the individual's body weight, the isotopic enrichment of the dosing water, and the isotopic composition of the urine and breath samples. Doubly labeled water provides an average measure of energy expenditure over the period of measurement, which is typically several days. This allows for the calculation of an individual's average daily energy expenditure. Doubly labeled water can also be used to estimate energy expenditure over shorter or longer periods, depending on the specific research question. Doubly labeled water is considered a highly reliable and valid method for measuring energy expenditure in humans. Its accuracy is supported by numerous studies comparing doubly labeled water measurements to those obtained by other methods, such as indirect calorimetry, which measures the oxygen and carbon dioxide exchanged during breathing, and doubly labeled acetate, which estimates energy expenditure by measuring the elimination of labeled acetate from the body. Furthermore, several studies have shown that doubly labeled water provides accurate estimates of total energy expenditure across a wide range of populations, including adults, children, and pregnant and lactating women. Doubly labeled water is also considered a safe and non-invasive method, with no adverse effects reported in the literature. However, like all methods, doubly labeled water has some strengths and limitations. Strengths of doubly labeled water include 1. Accuracy. The doubly labeled water provides a highly accurate measure of energy expenditure in humans, which is supported by numerous studies comparing it to other methods. 2. Non-invasive. Doubly labeled water is a safe and non-invasive method that does not require any invasive procedures or blood sampling. 3. Validity. Doubly labeled water is a valid measure of energy expenditure and has been used successfully in a wide range of populations, including adults, children, and pregnant and lactating women. 4. Long-term measurements. Doubly labeled water provides an average measure of energy expenditure over several days, which is useful for studying longer-term patterns of energy expenditure. 5. Versatility. Doubly labeled water can be used to study a range of research questions related to energy metabolism, such as the effects of diet, exercise, and environmental factors on energy expenditure. Limitations of doubly labeled water include 1. Expense. Doubly labeled water requires specialized equipment and expertise, which can make it expensive and difficult to access in some settings. 2. Time consuming. Doubly labeled water requires repeated urine and breath sampling over a period of several days, which can be time consuming and may require significant effort from study participants. 3. Inaccuracy. In some populations, doubly labeled water may be less accurate in individuals with certain medical conditions or with high protein intake. 4. Lack of short-term measurements. Doubly labeled water provides an average measure of energy expenditure over several days, which may not capture short-term variations in energy expenditure. 5. Limited information. Doubly labeled water provides information on energy expenditure, but it does not provide information on specific metabolic pathways or the composition of energy expenditure. Overall, doubly labeled water provides a non-invasive and accurate measure of energy expenditure in humans, and its use has been validated in numerous studies. However, the process of measuring energy expenditure using doubly labeled water can be time-consuming and requires specialized equipment and expertise. In conclusion, the assessment of physical activity with doubly labeled water can provide valuable insights into the physical activity behaviors of individuals and populations. Through this blended learning course, we hope to have provided a solid foundation for understanding the use of doubly labeled water in assessing PA, and to equip you with the knowledge and skills needed to effectively apply this tool in your own research and practice. Thank you for your participation in this blended learning course, and I wish you all the best in your future endeavors.